Hey everyone, in this video I'll be using the UUS animation set's extensive coverage to enable our character to strafe facing into and away from its direction of movement. Additionally, I'll be creating a spin state to facilitate more natural looking transitions between strafing nodes. If you are not following along with the UUS animation set, you might find some useful information in this video, but most importantly, the future videos in this series will not rely on anything that I set up in this video, which means that if you're unable to follow along with the steps that I take in this video, that will not stop you from following along with many future videos. I'm trying to build this system up in an iterative manner so that even if you don't have as much animation coverage as I do with the animations that I'm using, you can follow along as far as possible with the coverage that you do have. With that said, let's go ahead and get to the video. To start, I'll create an enumerator so that we can track the hip facing of our character. I'll open the content drawer and create an enumeration, and I will name it E_hip facing. I'll give it two enumerators, one named F for forward, and one named B for backward. I'll save and close out of this, and go into our base animation blueprint. Because the hip facing is tied to animation, we want to update it when we change between different directional animations. So I'll add some logic to update a new hip facing enumeration variable inside of our update locomotion direction function, which I'll rename to calculate locomotion direction and hip facing direction. I'll open up our function, and now, if you recall, this has two main sections. One where we test whether or not we're still within a dead zone added to our current direction, and if true, we return our current direction. And the other section, which is only evaluated when we are switching from one direction to another. And this is where we want to update our hip facing. I'll go ahead and create a new variable named hip facing direction, and I'll set its type to the enumerator that we've just created. We know that the hips will be facing forwards when moving forwards and backwards when moving backwards. So I'll go ahead and set this variable for each of those directions before we return from this function. I'll set it to backwards for backwards and forward for forwards. Things would get a bit more complicated for left and right. I'll go ahead and select this grouping of nodes and move it down so that I have some more space to work with. Now, what we set our hip facing direction to is actually going to be determined by the direction that we previously had before we switch to right or left. For example, if we're moving from forwards to right, we'd want to face forward into movement, as that would be a more natural transition to make. But if we were moving backwards previously, it would make more sense to face backwards into movement. The character can later enter into a spin transition to align itself with a desired hip facing for a movement direction. I'll go ahead and get a select node, and I'll get our current direction input for this function. I will plug it into the select node and take the return value and use it to set our hip facing direction enumeration variable. I'll insert it between this branch and this return node. We know that we want to return forward when our previous direction before we update it is forward, and backwards if our previous direction is backwards. For right and left, our new hip facing is going to be determined by our previous hip facing, as we could be either facing forward or backward into motion. I'll go ahead and get our hip facing direction variable, and I'll get a select node. I'll plug the result into the left input of our second select node, the first one that we placed, if we were previously moving left and our hips were facing forward into motion, then when switching to move right, our hips will face backwards into motion. And if we were previously facing backwards, they should now be facing forwards. Now, because we handle cases where we maintain our current direction in this section of this function, this right select input pin should never be returned by this node. So it does not matter what we input into it. That said, I don't like leaving incorrect values in any sort of nodes, even if they would never be used. So I'm going to plug our hip facing direction into the right input. That way, if it were to be called, even though it never will, we just maintain the same hip facing direction. I'll move this grouping of nodes down. I will copy it and paste it above so that I can plug it into the left direction return node. Most of the inputs here are correct. We just need to switch our left and right inputs. I'll go ahead and compile this, and I'll go into the event graph, and I'm going to place a print string node. I don't think I've used this yet in this series. It's very useful for debugging, and what I'm going to do now, although I've prepared this logic ahead of time, is show you the process I'd go through to test this sort of logic to ensure that it is functioning properly. Now that I have this print string node, I'll bring out my hip facing direction variable, plug it in to the in string input, and a conversion node will automatically create it, and there are conversion nodes for most variable types. I'll set the duration to 0, as this is going to be called every frame. If it was set to 2, the string would remain on the screen, and we'd get a whole line of strings that would never leave the side of our screen. I'll compile, save, and go back into the third-person map, and now we can see our hip facing is set to forward when we're moving forward, backwards when we're moving backwards, backwards when we move left from backwards, forwards when we move left from forwards, forwards when we move right from forwards, backwards when we move right from backwards. Now, if we're moving forwards and left and I switch to right, it gets set to backwards. And if I'm moving backwards from right and switch to left, it's moving forwards. Finally, if I'm moving forwards and right and switch to left, it should be set to backwards. And backwards and left and switch to right, it should be set to forwards. Those are all the conditions, and the string printed in the corner printed as expected. So now I know for sure that this logic works. And well, that's just how I'd go about debugging and testing logic like that. And I wanted to include that process in the video. And hopefully it can help to create a visual explanation for the logic as well, even though the animations are not updating according to the logic yet. Speaking of which, that is the next step. So I'm going to go ahead and open the content browser and open up the Locomotion layer's animation blueprint from the previous video. I'll go into the cycle locomotion layer and enter into this update cycle anims function that we've previously created. Currently, we have two variables using a strict type that we've previously created for directional animations, one for walking and one for jogging. I'm going to open up the variables panel here, and I'm going to copy one of these. I'll start with walk. I'll rename it to cycle animations walk underscore HF for hips forward into motion. I'll copy and paste that one and rename it to HB for hips backwards into motion. I'll do the same for the jogging variables, creating an HF variant and an HB variant. I'll add all of these variables into the settings category. And I'll go ahead and drag out our walking hips forwards and walking hips backwards variables. I'll get a select node, I'll get a property access node, and access our hip facing direction variable. I'll plug that into the index input, and now I'll plug the walk hips forward animation into the select node, as well as the walk hips backward animation variable. I'll go ahead and delete this standard cycle animations for walking variable. I'll drag out from the return value of the select node, and I'll search break and select this break f directional anims node, which allows me to break a struct into its components. I will plug each of these components into this select node, and I'll go ahead and organize this a little bit. And now I'll duplicate this grouping of nodes and plug everything in for jogging. Now I'll go ahead and grab the jog variables and swap them out. Alright, now our update cycle anims function will update to the cycling animations according to the hip facing as well as the gait and direction. I'll go ahead and compile and save and open up our Locomotion layers unarmed animation blueprint. Here we have our new struct variables. I'll go ahead and select the appropriate animations. For the hip forward variables, the right and left slots both have the hip forward facing animations. The inverse will be true for the hips backward animations. The forward and backward animations are the same for each of these sets. I'll go ahead and compile, save, and go back to test. Now, it looks like everything is working properly. Our hips can either face forwards or backwards into motion for right and leftward strafing movement. I'll go ahead and go back into the Locomotion layers blueprint and delete the old cycle animation variables for walking and jogging, as we do not need them anymore. I'll compile and save, and now the next piece of functionality we need to add is the ability to update the hip facing direction according to a setting. Right now, our hip facing is selected based on our previous direction, and it never changes. We'll either be stuck with our hips facing backward in the motion or forward in the motion perpetually, depending on whether or not we started in the forward or backwards direction, depending on the direction that we started from. I'll go ahead and go back into the base animation blueprint and create a new variable. I'm going to name it desired hip facing. I'll change its variable type to our Locomotion direction enumeration, and I'm going to change the variable container to be a map, which allows us to map values to our Locomotion direction enumeration. In this case, the type of the value we're mapping is going to be our hip facing enumeration. If I compile, I can add a map element for each of our directions. It will only let me add one with the default element for this enumeration, which is forward. So I'll need to change this to a different one and continue to do that to get all four, with the last one that I add being the forwards direction. Now these are our desired settings. So forwards is going to be forwards, backwards is going to be backwards, and I'll leave left and right as forwards for now. To facilitate updating our hip facing direction, I'm going to implement a spinning state into our Locomotion state machine. You do not need spin animations to follow this approach. However, spin animations will work optimally with it. But before I show you a spin animation implementation, I'll go ahead and show you how to do this with regular cycling animations. I'll drag out from our cycle state and I will create a state named spin. For the condition for our transition, I'll grab our desired hip-facing map. I'll drag out from it in search find. I will plug in our hip-facing. I will plug in our locomotion direction enumeration. And we now have the desired hip facing for our current direction according to the desired hip facing variable. I'll grab our current hip facing, drag out from it, and I will check if our current hip facing is not equal to our desired hip facing. If this condition is true, then we will transition into the spin state. To transition back to cycle from our spin state, I'll create a new transition, and I will go ahead and check this automatic rule based on sequence player in state condition. This will automatically bring us from our spin state back into our cycle state when the animation played within the spin state is complete. There's one more thing that I almost forgot. In this transition into our spin state, if this is our only logic, we will immediately switch to our spin animation and switch to our desired hip-facing direction, and so we might as well not even start from an undesired hip-facing direction. I'll go ahead and get an AND Boolean node here, and for our second condition for this transition, I will search get relevant anim time remaining. This is going to provide me with the time left in the animation being evaluated within the cycle state. I will check if the time remaining is less than 0.05. I'll plug that into this AND node, and now we will only switch into our spin state when our cycling animation has almost finished. And this should ensure that the transition lines up with the spin animation fairly well. Now we need a spin layer in our animation layer interface to plug into our output animation pose for our state. So I'll open up our locomotion layers interface. I'll add a new animation layer named locomotion layer underscore spin. I'll compile, save, and close out of our interface. And now I can grab our spin linked animation layer and plug it into the result for this output pose node. Now, before I show you the two approaches we can take for this spin layer in our locomotion layers animation blueprint, there's one more piece of logic for this puzzle of our hip facing direction adjustment system that we need to put together. And that is updating our hip-facing direction enumeration whenever we return from this spin state into our cycle state. I'll go ahead and enter into this cycle state, and on this output animation pose, I'll bind a new function to the onBecomeRelevant binding. I will name this function setUpCycleState. I'll get our desired hip-facing map, and I will find the hip-facing that corresponds with our locomotion direction, and I will set our hip-facing direction with the result that we find from our map. So now, regardless of what our hip-facing direction is, when we first enter into this cycle state, we will always set it to correspond with our map variable. I'll compile and save, and that is going to be it for the time being in this animation blueprint. I'll go ahead and switch into this locomotion layers animation blueprint. I'll copy all of the nodes within our cycle layer. I'll enter into the spin layer, paste them, and plug them in. I'm going to uncheck the loop animation boolean here, and now I want to show you the result using the cycling animations. Our desired hip facing for moving left is forwards, so if I start moving backwards, the character spins and switches facing directions. Now this is about as best as I can do with just using these cycling animations. It's a simple spin around transition from one direction to another. This can be made to look better using a foot placement node, which I'll be covering later in the series, but in this video, I'm going to show you how we can take this to the next level with the UUS animation set and incorporate its spin animations. I'll unbind the update cycle animations from the onUpdate binding of this sequence player, and I'll create a new function bound to onBecomeRelevant named setUpSpinAnims. I'll give myself some room between these two nodes, and I'll search set sequence with inertial blending, and I'll select the one that corresponds with a sequence player. I'll plug this in between these two nodes. I'll plug in the context, and I'll get a sequence player conversion node for our node input for the function and plug that into the sequence player input for our set sequence function. I'll leave the blend time as 0.2 for now. You can adjust it to your liking, and I'll drag out from this sequence pen, and I will get a select node. Now, the animation we select is going to depend on our locomotion direction, so I'll get a property access node, get our main animation blueprint and our locomotion direction, and plug that in. We're not going to be spinning from the forward or backwards directions, so I'll go ahead and grab our standard cycle animation variables for walking and jogging. As the forward and backward animations in these are the same, it doesn't matter whether we use the hip forward or hip backward variables. I'll get another property access, and I'll retrieve our gate enumeration from our main animation blueprint and get a second select node. I'll plug the result into the forward of our final select node. I'll break the struct pin for each of these variables. I will plug the forward walking animation into our walking input and the forward jogging into our jogging input. I will duplicate this grouping of nodes and plug in our backwards animations and plug the result into the backwards input of our select node. We'll need to choose different spin animations based on our gate, so I'll copy these select nodes and plug one into right and another into left, and I'll go ahead and plug our current gate into each of these. Now I'm going to create a struct that we can use to store our spin animations. I'll go ahead and duplicate the directional animation struct and rename it to be f_spin_anims. I'll open it up and delete the right and left entries out of the struct and just leave the forward and backward entries. I'll create a new variable inside of this animation blueprint, and I'll name it spin animations _walk_r. I'll set its type to be the struct that we've just created. I'll duplicate it for left, and I'll duplicate each of these so that we have a jogging right spin animation variable and a jogging left spin animation variable. I'll add each of these to that settings category. And now I'll go ahead and bring in this walk right spin animation variable. I'll drag out from it and get a break node for our struct. I'll get a new select node, and I'll get a new property access node. For the property access, I will get our current hip facing direction, and I'll plug that into the select node. I'll plug the forward sequence into forward and the backward sequence into backwards. I'll duplicate this grouping of nodes and swap the animation variable out for our walk left variable. I'll duplicate these two and swap the walk variables out for our jog variables. Now I'm going to plug these groupings into the corresponding select nodes that are using our gate enumeration as an index. So for the one that is plugged into our right input of our final select node, I will plug in the walk right variable select, and I will plug in the jog right variable select. For our final select node, I will plug in the jog left and the walk left into the corresponding inputs. I'll go ahead and compile and save, and our logic for selecting spin animations is complete. I'll go ahead and go into our Locomotion layers animation blueprint, and if I compile and go to class defaults, our settings should appear for our spin animations. For the UUS animation set, under our walk right variable, I will search walk spin, and I will select for the forward entry right forward to right backwards 90. I'll search the same thing, walk spin. I'll go ahead and copy this so I don't have to type it in each time. And for the backward entry of our walk right spin animations variable, I'll select right backward to right forward. For walk left forward, I will select walk spin left forward 90 to left backward 90. And for left walking backwards, I will select the spin for walking left backwards to left forwards. And I'll copy this pattern for our right jogging spin animations and our left jogging spin animations. Now that the animations have been selected, I'll compile, save, and go back to our third person map. If I begin moving backwards while strafing right, the spin animation will play. If I move backwards while facing left, the spin animation will play as well. However, we can run into some issues when changing directions while playing spin animations. This doesn't look too terrible, but I'm going to go ahead and add a second transition out of our spin state. So I'll drag from spin to cycle once more to create a second transition. And for the condition of this transition, I'll get our locomotion direction and an equal enumerator node. I'll plug the result into the result of our transition, and I want to compare our current locomotion direction to a previous locomotion direction, so that if our direction switches while we're spinning, we abort out of the spin state straight back into the cycle state. I'll go ahead and go into the update orientation data function that we've previously created, and before we set our locomotion direction, I'll get our locomotion direction and set a new variable named previous locomotion direction. So now we are tracking the locomotion direction for the previous frame. I'll go back into the spin to cycle rule and get our previous direction variable and plug it in. I made a mistake. I've put an equal node in here, but I meant to put in a not equal node. If we spin and we switch directions, we exit the spin state. These spins do not look good when pivoting from moving one direction straight into another. In some circumstances, The character will spin around in an odd manner when moving from one direction to another, and this will be resolved when we add a pivot state into our locomotion state machine. In most cases, the result looks passable, but in some cases, either the character does a full rotation and continues facing the same direction, or something else odd happens. But we will not be spinning when pivoting in the future, so that isn't something I'm going to worry about resolving in this video. And if the issues persist after I add a pivot state, I will address them then. Additionally, if I use a gamepad here and move at an angle, the spin animations still work properly as I'm using orientation warping inside the spin layer. Finally, one last thing, just to demonstrate here, I'm going to change around the desired directions here, just to demonstrate the functionality. I'll change left to backwards and right to backwards. I'm not sure why anyone would want to do that specifically, but it'll work for demonstrative purposes. If we're moving forwards and in either the left or right directions, we will spin. If moving backwards, we will not spin. And if I try to get a good switch from right to left, we will spin to face backwards as we switch to moving forwards. Now, the transitions are not perfect. You've probably noticed the slight misalignment, and don't worry, I've noticed it too. I will be making an entire video in this series that will be dedicated to ensuring that animations sync properly within our locomotion system. It's a big topic, so it's not something I want to cover bit by bit in each of these videos, and I'd rather address it all at once in its own video. All right, everyone, that's going to be it for this video. Thanks for watching, and I'll see you in the next one when we will finally be finishing up our cycle state.